In SQL, as in life, sometimes you need to look back on where you've been and forward to what's next. And the lag and lead window functions in SQL Server Management Studio allow us to do just that. Hi, I'm Brian Amrine with Value Driven Analytics, publishing analytics training videos, including SQL training videos, at least once a week, so please consider subscribing. But today we'll be focusing on the lead and lag functions in SQL Server Management Studio. Now, the lead and lag functions can be used in many other versions of SQL as well, such as Teradata or Snowflake, many others. But today we'll be in SQL Server Management Studio, so let's head over there now. Now, the lag and lead window functions are very simple, so you don't necessarily need to follow along with the exact same code I'm running today. You certainly can, but choose a table where this concept could apply that you have access to in the SQL database that you're using, and try to apply the concepts we're using there. The database I'll be using today is called Value Driven Analytics. As you can see here, I've already created that. I'm going to create a schema, which is a folder of tables within a database called the lag and lead illustration. And then I'm going to create a table within that schema called marketing interactions that, as you can imagine, has one row per marketing interaction. So I'll run this code to create that template. This is not part of the lag and lead function. I'm just showing you how I'm setting up the table. The table that we're going to be looking at today has 7 rows in it. Very simple table. We're going to manually insert these 7 rows in, and then the first thing we're going to do is to take a look at what our table looks like. It's a great place to start. So you don't need to have done any of that. We just did this for our setup. Of course, you can if you'd like. Let's take a look at our data set. All right, we've got marketing interactions, and we've got several columns. We've got a customer column, a marketing channel column, and an interaction date. So on September 1st, 2023, Sam interacted with the website. On October 17th, 2023, Brent interacted with the website, and so forth. What you'll notice here is we've got the rows in here in a specific order. They're not necessarily ordered by date. So you'll see Brent has 2 interactions on the same day here, one with website, one with direct mail, another one on the 19th with the website, and then the interaction on the 15th actually comes after that. So they're not in order by date. I wanted to show you that, this example to show you what happens in a scenario like this where they're not necessarily ordered by date by default. And that was an interaction with social media. And then Susan here has 2 marketing interactions, one on October 25th, one on November 25th, social media, direct mail. So that's the data set we're looking at. Now, our use case today, where lag and lead can come in handy, is trying to be able to tell what was the previous marketing interaction to the one in question. We might need that for a particular analysis we wanted to do. So I'm going to keep all the columns selected with select star here, but I'm also going to be adding this. First we'll do a lag example. And basically what lag is going to do is it's going to reference the previous row according to some criteria. So the first thing we'll need to tell it is we'll use the keyword or the function lag, open parentheses, and we need to tell it what field do you want to see the lag of? What field do you ultimately want to be populated here? We'll start with interaction date. We want the previous row's interaction date. Okay, so we'll start with that. Now you also need to have an over statement. So we'll add over here, and that'll be followed by an open parentheses. And within those open parentheses, you'll have a partition by. This is optional. We'll show what it looks like with and without. Partition by is at what point do you want your lag to kind of start over. I don't want to see a lag within, unless it has the same value in this particular column. So for us, we'll start and say that's customer. We're looking for a customer's previous interaction date. We don't want to see necessarily like a past interaction if it's for a different customer. So in this case, we would put customers or partition by, if that were the case. And then we also need to have an order by statement here. And this is going to tell us what order should we look at to find that lag? And this could be a numeric variable, could be a character variable, an nvarchar. It would be alphabetically ordered if it's that case, or a date variable, which is what we're going to use in this case. So we'll do interaction date. What was the previous day's interaction? All right, so that'll be our lag statement here. So it starts with lag, and then you feed it the name of a field. There we go, interaction date. The field you want to have it returned over, and then this is within this group, within this field, the same value of this field that we put in the partition by, and then ordered by interaction date. We'll just call this our lag variable. Take a look and see what this returns. All right, we have a new variable, of course. We've aliased it and called it lag variable. What you'll notice first and foremost is it has reordered our table a little bit. So now it has Brent at the beginning. And what you'll notice here is 1015, the Brent's earliest interaction doesn't have a value. There was no value before 1015, and so it's null in this case. And then notice what happens next. Website, it makes sense that that interaction was on 1017, and so it is pulling in 1015, which would have been the previous marketing interactions right there. Now this is important. Remember, there was Brent in particular had a website and direct mail interaction on 1017. So those happen on the same day. Notice for the direct mail interaction on 1017, the lag ends up being 1017, which was the previous interaction, happened to be on the same day. So why did it choose to make the lag 1015 for the website and 1017 for the direct mail, even though both of those were on October 17th? Well, let's look at the order in which the rows are inputted. The website 1017, that was the first one that came in the series, and so it said, okay, the row before that would have been 1015 on date. So it did resort these based on date, but then within that, it's using the order within the table. And then came direct mail. Now, if there was something else you wanted to sort by, if we wanted to sort by, let's say, marketing channel as well, we can break some ties. So in this case, this will actually sort direct mail before website because it comes first. So I'm going to expect direct mail now to have a lag variable of 1015 and website to have a value of 1017, now that we've ordered by marketing channel after interaction date. So you can order by multiple things, you can partition by multiple things. And there you go. Direct mail now is coming first, and its lag variable is 1015. Now the website interaction has the lag. It's just looking at the direct mail one, because now we're sorting on marketing channel as well. Before it was just based on within, if two rows for the same customer for the same interaction date, it's using the one that came first in the table by default. But now we're adding a tiebreaker here. Now, what if we just wanted to not even group by customer and just say, what was the previous marketing interaction in general? We would just take this partition by out. We don't have to kind of group like we were before with the partition by. So now it just pulls the earliest one in the data table, which was September 1st, then October 15th, and so forth. So notice now Brent's 1015 social media interaction, it is pulling in a lag of Sam's interaction, since that was the one that was before that on September 1st in the table. So there's no partitioning happening in this example. Now, what if you didn't even want it to be based on date? You just wanted to know the previous record in the table. That's a little tricky. But it doesn't have to be. There's actually kind of a way you can reference you have to have an order by statement in here. So you might think, oh, I just want the previous lag. Let me just get rid of this entire statement. That's not going to work. It's going to throw an error. As you can see, you don't have to have a partition by statement like we don't here, but you have to have an order by statement. And so if you just want it to be ordered based on the order of the rows, instead of putting in a regular field here, you'd use this percentage physloc. Show that right here. Now watch what happens. So see how the 1015 row was put at the beginning, or the second row here, because it's the second row based on date, but in reality it's the fifth row in the table. Now that's going to change because we're just ordering on the location of that row in the table. Yeah, now that September 1st gets associated with the next row in the table, and notice 1015 is way down here because it's in the position that it is in the table. It's the fifth row, and so it's being associated with, its lag is technically 1019 based on 1019 being just the previous row in the table. So if that's how you want to set it up, you can use this percentage physloc. That's kind of neat. Now, what if you wanted to, let's just go back to our more realistic example where we were partitioning by customer and ordering by interaction date. Let's say you wanted to get the lag not just one space back, but two rows back, according to the order by. You can just add a comma 2 in your lag statement here. No, so the default is 1, a pretty good default to assume that I just want to go back by 1, but if you want to go back by another amount, just use 2 instead. And now you'll notice there's 2 values that are null here because both of these don't have a record that's 2 back. This row would have one that's 1 back, but not 2 back, and so it's null. But these 2 do. Now we can also get the lag based on a descending date. Let's just see what happens when we do that. We'll just add in the DESC. The default is ASC, ascending order. We can also spell that out. In this case, we'll do descending interaction date. We're getting the lag based on a descending interaction date, which is really like getting a lead. So let's see what happens there. Now, all of a sudden, 1015 has a lag, which is really a lead. It's a lag if you're going by the interaction date descending. So it's almost like you can get this lag to work as a lead as well. Of course, you want to make this as intuitive as possible. So that's where, if you really wanted to do this for an interaction date, I just go ahead and set this to lead instead of ordering by descending, but technically either one would work. So let's look at what the lead function does. It's basically the equivalent. So here we go, 1015 associated with 1017. And then we don't have leads. We don't have any records for what we're partitioning by. For the value of Brent for customer, there are no records that are 2 rows ahead for 1017 or 1019 for these last 2 rows here. And so the lead is null. So keep that in mind. Now you might say, oh, great, I want to filter on that now. Well, these lead and lag functions can only be used in the select statement or the order by statement. So if we try to apply a where statement to this, maybe we say where this lead is greater than or equal to 2023 1019. We want to apply that where statement here. I think I need to update this to a single quote. So that's one thing. Okay, so you can see here the windowed, we got an error. Windowed functions can only appear in the select or order by clauses. So how do you get around that? Well, a quick way is just to put this in a subquery, or a CTE would work as well. So if I do a select star from, and then we got to put this in a subquery now. And I would recommend indenting your subquery just for formatting purposes. You've got to give a subquery an alias. Just use A in this case. Now it would actually be called lag variable. It actually exists as a variable inside of the table. Now we can reference that variable name we gave it, lag variable, and let's see what our results are. There we go. We only get 1019. Notice all the nulls get filtered out when you filter on a value. If it's null, it's not going to come through. If we wanted to include nulls as well, one option for that would be to add an or statement here. If you're going to have multiple, you probably want to put all this in parentheses. Let's say a lag variable is greater than or equal to October 19th, 2023, or that field is null. And that's going to bring in the nulls as well. So that's one way around that. So I wanted to show you how you can filter on this. Fortunately, you kind of have to run that query, create it as a subquery, and then filter on it. Well, again, a CTE. Creating this as a CTE would work as well. Let's go back to our original query though. I want to show you a few other things. So we've walked through lead, we've walked through lag, we've walked through how a lead can become a lag just by changing the order that the way you're ordering, ascending versus descending can change a lead into a lag and a lag into a lead. So there's all kinds of ways you can make this work. I'm going to go back to just using a lead of 1 here. And actually, let's change it back to a lag. Just a really simple use case that we started with. One thing we found here was, again, that the direct mail part here, it shows that the last interaction date for the direct mail was 10/17, which is the same day. What if we wanted that really to represent, now what was the previous date that they received an interaction? So for both the website and the direct mail interactions on 10/17, we want them both to have 10/15. What if we wanted to accomplish that? Well, we need to take some SQL techniques and kind of bring them all together here. The first thing we need to do here is deduplicate our table. In this case, if we can just get the table down to 1 row per customer interaction date combination, we should be able to get around this issue of having 2 interactions for Brent on the same day. It'll just show up as 1 row for 10/17. So we'll do that through a subquery here. I'm going to write subquery indented, so we do that with the open parentheses, and we'll do select distinct on the customer field, get distinct combinations of customer and interaction date. That'll be our inner query, and that'll be from the same table we were using. We'll close that off with a closed parentheses. We've got to give our subqueries an alias. I'll just call it A here. Let's just take a look at what the inner query generates. So now when we run the lag on that, let's see what that looks like. Perfect. So now 10/17 is associated with 10/15. That's the previous interaction day, and so forth. Now, unfortunately, in the course of selecting distinct on customer and interaction date, we have lost our marketing channel column. So how do we get that back? How do we make this still 1 row per customer marketing channel interaction date combination like the original table? We only have 6 rows here because the 2 rows for Brent, the marketing interactions that happen on the same day, have been consolidated into 1. How do we get our original table back, but with this new lag variable? Well, we can take the result of this and join it to our original table. So it's a little complicated here, but it's kind of a complicated use case. So I'll do select star, start with from our original table. Just copy that from up here. And then we could do a left join or inner join. So we'll do an inner join since either one would work. That tends to be more efficient than a left join. When you have a large table, it might make a difference. Okay, so then we'll have this as our table we're joining in on. I'll just give this an alias of AA. I'll need to assign aliases to all our tables here, so I'll go ahead and I'm going to use AA for this first table, actually, our original table. And then I'll use alias of B and BB here. Okay, so we actually have an inner query and then an inner query here. And then this will be our outer query that we're working on now. So the way we're going to join the original table to our updated lag table is going to be through the customer field and the interaction date field. So we're saying AA.customer equals BB.customer and AA.interaction date equals BB.interaction date. So So we want both of those marketing interactions on 1017 for Brent. We want them to have the same lag variable field, which is 1015. And so we're joining on customer and interaction date. Since both of those rows have the same customer and interaction date, they're going to have the same value of lag variable, which we'll see here. All right, so we're joining on customer equals customer, interaction date equals interaction date. That looks good. I'm just going to select everything from our main table, and then I'll just select the lag variable field from table B. Let's see if that works. Okay, what do we have? 1015, still null because there was no previous row for Brent, and we're partitioning by customer in this case. Look at this, those two 1017 rows, they're both back because we started with our original table, but now both of them have a value of 1015. Very cool. So that's just one way that you can handle cases where there's duplicate rows there. It's a creativity technique where you're bringing in together multiple SQL techniques, the distinct, using subqueries multiple times in this case, the lag variable, joining tables together, all of those are being brought together to create a solution. And that's just an example of how flexible SQL can be. We did all this in one final query, which is pretty neat. We didn't have to create multiple tables or anything. So that's just one example. Now, I also want to mention in this case, we were bringing back the interaction date. We don't have to bring back the same thing that we ordered by. If we wanted what the previous marketing channel was, for instance, I'll just run the inner query here. We can do this. We can pull the previous marketing channel based on the previous interaction date, since that's what we're ordering, within that particular customer. And that'll work just fine. So in this case, we've removed marketing channel, so I'll just pull from the original table here. Let's just look at that. Okay, so now you can see it's pulling the previous marketing channel based on the date, previous marketing channel. Now again, it's still, we've kind of simplified it here, so it's pulling website for this direct mail one, and lots of ways you could handle that if you wanted to have some kind of a rule for determining what the previous marketing channel was. But now it's returning the marketing channel instead of the thing we were sorting by. So much flexibility with these lag and lead statements. And now you know how to lag and lead. I hope you enjoyed today's training session, and if you did, please consider liking the video. If you'd like to see more of these, consider subscribing to our Value-Driven Analytics channel. And if you have any questions about what we discussed today, please consider leaving a comment, and I'll do my best to respond in a timely manner. That's it for today's training. Now it's your turn to apply your new SQL knowledge.